Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, Official Guide to the Revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we're about to solve is the one that you will find on page number 231. And today is our lesson number 324. It's a problem very similar to the problem that you see on page number 231. It's not exactly the same one. It's a bonus problem. The problem that you see on page number 231, 2.7.4, is something that we did yesterday. In today's problem, we have three characters, A, B, and C. We are told that A can do the job in 2 hours. We are told that B can do the job in 3 hours. And then we introduce this character C, and C we are told can do the job in 5 hours. The question is, how long does it take them to do the job together? And here are the answer choices. Now, I hope that you have watched yesterday's video. It is always important, it is always vital, it is always crucial, it is always imperative that you watch these videos in sequence, because otherwise it's difficult, things build up on each other. Do you understand? Yesterday, I made a point of telling you that make sure that you do this problem and you try to solve this problem yourself before you watch today's videos. If you have not watched yesterday's videos, you'll have a little bit trouble understanding it, because I'm not going to go through all the concepts one more time. So as you know, we have two methods to tackle this problem. Here's the first method. So I need the room. We need a lot of room. So what we're going to do is we're going to make a note here. 2, 3, and 5. We're going to make a note. 2, 3, and 5. A was 2, B was 3, and C was 5. Here's how it goes. If the two faster people, if the two faster guys work as slow as the slowest guy, if the two faster guy work as slow as the slowest guy, the job will take a certain number of hours. If the two faster guys, I don't know why they have to be guys, why couldn't they be gals, I don't know. Perhaps it has something to do with gender stereotyping, I don't know. If the two faster guys work as slow as the slowest guy, we will ask ourselves, how long will the job take in that scenario? On the other hand, if the two slower guys work as fast as the fastest guy, the job will take this many hours. So, what's the answer? If for some strange and inexplicable reason, the two slower guys are these two guys, C and B, B and C. B takes 3 hours, C takes 5 hours. A is the fastest one, A only takes 2 hours. If for some strange and inexplicable reason, both B and C decide to put their derriere in the 5th gear and decide that they're going to work as fast as the first guy can do the job in 2 hours. So if all three of them begin to work at the same pace, each one of them finishing the job in 2 hours, then in 2 hours time we'll have 3 jobs done. If three jobs will be done in 2 hours, so one job will take 2/3 of an hour. Whatever the amount of time the fastest guy was taking, it will be 1/3 of as much, because we have 3 guys working now instead of 1 guy. So if the fastest guy is taking 2 hours, if other two started working at the same pace as the fast guy, then whatever the amount of time the fast guy is taking, it will be the third of that time, 2/3 of the hour. In other words, the job cannot take less than 2/3 or equal to 2/3. It will not be equal to or less than 2/3. That's the best case scenario. It is purely hypothetical because we know that the two slower guys are not working as fast as the fast guy. So any answer choice that is equal to or less than 2/3 is nonsensical. Do you see any answer choice which is 2/3 or less than 2/3? Well, there's 2/3 right here. A is not the answer. Now let's look at this one. If for some strange reason two fast guys are the guy who can do the job in 2 hours and the other guy who can do the job in 3 hours. These are the two fast guys. If for some strange inexplicable reason, if the two fast guys decide to work as slow as the slowest guy, who takes 5 hours, now we got 3 people working there, each of them taking 5 hours to do the job. If 3 of them are working together, it should take 5/3 the amount of time. 5/3 of the hour is what I meant to say. 5/3 of an hour. 5/3 of an hour is 1 2/3. This is the worst case scenario. The job can never take more than or equal to 1 2/3. In other words, the correct answer, whatever it is, has to lie between 1 2/3 and 2/3. Do you see any answer choice which is equal to 1 2/3 or more than 1 2/3? Well, I see 1 2/3 right here. It cannot be C. It cannot be D. The D is more than 1 2/3. It cannot be E. Voila, there you go. The answer is 1. I think I left out something very crucial yesterday. I am so sorry. What I left out in this problem was the word approximate. In the exam, they tell you approximately how long it will take. And the answer is, it will take approximately 1 hour. It will take approximately 1 hour. Now let's do the second method. Yesterday we did the problem 2 different ways. Now let's do the second method. Second method is the LCM method. LCM method. That's it, we're done with this guy. I'm going to erase this thing. I'll give you a second to absorb it if you like, while I absorb some liquid. Now remember, the question is approximately how long? Approximately how long it will take for them to work, to do the job if 3 of them are working together. Here's the second method. This is what I call the LCM method. It is called LCM method because here we look for the least common multiplier. Least common multiplier of 2, 3 and 5. One guy takes 2 hours, the next guy takes 3 hours, the third guy takes 5 hours. The least common multiplier is 2 times 3 is 6, 6 times 5 is 30. So let's look at 30. Let's look at 30. So let's ask ourselves, what would happen if they all worked for 30 hours? What would happen? What would happen if they all work for 30 hours? Well, we know in 30 hours they can do how many jobs? Say we are told takes only 2 hours to do the job. Well, if he takes only 2 hours, in 30 hours he can do 15 jobs. In 30 hours, B can do how many jobs? Well, B we know, B we are told, takes only 3 hours to do the job. Give him 30 hours and he can do 10 of these jobs. C, you give C 30 hours, C tells you that he can do a job, he can do one job in 5 hours. Well, you give him 30 hours, he can do 6 jobs. Let's add them up, shall we? So what we find is that together in 30 hours, they can do how many jobs? Let's find out, shall we? 6 plus 5 plus 6 is 11, so 31 jobs. 31 jobs in 30 hours. The question is, how long will it take them to do one job? Well, if 31 jobs can be done in 30 hours, then one job will take 1/31st hour. That's it. What is the answer? 30 over 31 hours. 30 over 31 hours is approximately 1 hour. Hence the use of the word approximately. And I feel so bad that yesterday, as I was putting the problem on the blackboard, I left out the word approximately. I left it out because I did not rewrite the problem. It was the same problem that we had yesterday, and I just inserted the new stuff in it. And I forgot to insert the word approximately. But anyway, so approximately, well, not approximately, it will take them exactly 30 over 31 hours. 30 over 31 is about 1 hour. The answer is B, which we already knew, of course. I will see you tomorrow, where we'll do the word problems that we see there at the bottom of page 231 and the very next one. Tomorrow, in the next video, I plan to do 2.7.5 and 2.7.6, so that we can move on to the concept of interest, the simple interest and the compound interest, which will be day after tomorrow. Anyway, I'll see you then, okay? Bye now.